Hello and welcome to this video for Algebra 2. This is a video that's going to be posted and you should be able to see it from Friday the 3rd of April, and any work that comes from it will be due before class starts on Tuesday, April the 6th. Okay, so where we are is in Chapter 6, Exponential and Logarithmic Functions in OneNote. And we're looking at the second page on Chapter 6, Solving Exponential Functions, Compound Interest Formula. And yesterday we did the solving exponential equation, so today we're going to look at the compound interest formula. So I'm going to scroll down through this work here, and we're going to begin looking today by talking about compound interest. So compound interest is something we're all familiar with. And the older you get, the more familiar you get with it, because you end up usually taking out more loans, like a mortgage, like student loans, car loans, and interest on those loans is charged by compound interest. There's also something called simple interest, but we rarely meet it in real life nowadays. Most of the time we're dealing with compound interest. So what does that look like? Well, when you open a savings account in a bank, the bank pays you a certain level of interest. So this is good news. If you put money into the bank, they give you some interest back. Now, if they give you simple interest, well, simple interest is a percentage of what you put in initially. Okay, so simple interest depends on what you put in at the start. That was called your principal. The amount that you invest at the start is called your principal. So simple interest is always based as a percentage of the principal, the first amount of money that you put into the account. So for example, suppose you invest $100 at 1% simple interest per annum or per year. So it's $100 at 1%. 1% of 100 is $1. So the bank will pay you 1% of $100. They will pay you $1 each year. And if you don't put in any more money into the account, they will always pay you $1. It doesn't matter if you've had the money in there for 80 years and now you're up to 180, they'll still be going back to the original 100 to figure out how much interest they want to pay you. Compound interest, on the other hand, is a percentage based on your most recent balance. So in the case of a $100 initial investment, with interest compounded annually instead of simple interest, you'd still get paid $1 at the end of the first year. But in the second year, you'd receive 1% of $101. Okay, so they pay you on the second year, they pay you interest based on what you had at the start of the second year. Not what you put in originally, not on your principal, but on what you had at the start of that second year. So you would get one extra penny. So this is just a very simple example, and after 2 years off, the person receiving compound interest is better off by 1% after 2 years off. After 2 years of investing, the person receiving compound interest is better off by 1%. But in reality, compound interest can make a huge difference, okay, and it really does. It makes an enormous difference. So the formula which allows you to calculate the amount of money in your account using compound interest is written there. A equals P. Let me just highlight that for you. That's a formula. You have to know that formula. Okay, you have to know that formula. A equals P times 1 plus R over N to the power of NT. Now, we haven't talked about what any of those things are, so that's coming up next. So A is the amount that you end up with. Okay, A is the amount that you end up with. Call it the amount. It's what you end up with. It's the final balance after you've been investing for T years. Okay, so T years. P is the principal. It's your initial investment. So the principal is what you started with. It's your initial investment. R is the rate of interest. Now, usually that's given as a percentage, but you have to convert it to a decimal. So let's go back to something like, I guess, 4th, 5th grade maybe. Converting percentages to decimals. Basically, you just divide by 100. Okay, so to convert a percentage to a decimal, you'll divide by 100. N is the number of compounding periods in a year. Okay, So if the interest is compounded annually, and you'll be told this in every question, if the interest is compounded annually, n will be 1. If the interest is compounded monthly, that means every month, so it'll be 12 times in a year, so n would be 12. If it's quarterly, okay, so every 3 months, that's 4 quarters in a year, so quarterly would be n equals 4. So let's just look at this example. And you're going to need your calculator to do it, but if we look at this example right now, it says a couple invests $8,000 in an account that pays 3.25% interest, compounded monthly, so that's important. Assuming they don't make any deductions, so they don't take any money out of the account, and ignoring tax, how much will they have in the account in 6 years? I'm not advising you to ignore tax, but to make this problem a little bit more manageable, we will do that. So a couple invests $8,000. So let's write out what we know about this. That means the principal will be $8,000. That's the principal. That's what your initial investment was. So the principal is what you put in initially. You paid 3.25% interest. That's an interest rate. You call that percentage an interest rate. So R is equal to 3.25. Now that's a percent. You want to change it into a decimal. So you divide by 100. And that's going to give you, you're going to move the decimal point 2 places to the left. So that's going to be 0.0325. Okay? Now it's compounded monthly. Now we said up here, compounded monthly means n would be equal to 12. Okay? So compounded monthly means n is equal to 12, the number of times in a year that this is compounded. Assuming they don't make any deductions from the account and ignoring tax, how much will they have in the account in 6 years? So we're going to have this in for 6 years, so the time is equal to 6. T is equal to 6. Okay. Now the question is, how much will they have in the account? What will the amount be? So the amount is the thing you're looking for here. Okay? Okay. Well, that's all the information, and what we're going to do now, we're going to write out the formula, and like I've always told you, write out a formula every time you need to use it. So A is equal to P times 1 plus R over N to the power of NT. So that's going to be, start to fill that in. A would be equal to P is 8,000 over 1 plus R was 0.0325 divided by N is 12, and all to the power of NT, so 12 times 6. Now the only thing I would advise you to do here, we're going to go to the calculator very shortly, but the only thing I would advise you to do is to do this first, okay? Do this before you do the calculator. So then we're going to have A is equal to 8,000 times 1 plus 0.0325 over 12, and 6 12s are 72. Okay, so now we're going to bring up our calculator. Just takes a moment for this to come to life. Okay, and let's pull it over here a little bit. Let me see if I can make this a little bit smaller, can I? Maybe not. Let's see if we can fit this in. Well, I think it'll be okay there, actually. We know that it's an 8,000. Let me pull this over to one side a little bit. No, I can't do that. Okay, sorry about that. So I'm going to clear what's on the screen here. And I'm going to start with 8,000. You can't see it's 8,000 behind the calculator, but we know it is. So just type that in, 8,000, and just type it in exactly as it is. Parentheses, 1 plus 0.0325 divided by 12. Close your parentheses, and we're going to raise that to the power of 72. And if we hit enter, we get 9719.9255. Okay, so 9719.9255. So 92, this is going to be money, remember, so that this so far this is dollars, and 92.55 cents. So round it off to the nearest cent. So that would be 93 cents. It's not quite 93 cents, but basically that's what it is. Okay, so after 6 years, who is it? It's a couple. After 6 years, the couple's initial investment of $8,000 has grown to $9,719 and approximately 93 cents. Okay, so that's how you do it. Just write out all your information. Try and get all the information from the question. Label all the numbers that are involved in the question. Write out the formula. Start putting it into the formula. I'd say always do this little bit up here first before you go to your calculator. Figure that out first, okay? Do that before you go to your calculator. And then once you've got to that point, go to your calculator, just plug everything in the way it is and go from there. Okay, I'm going to post some homework on VeroCross. It's going to be from your textbook, and you'll find the homework there as added on to watching this video. Thank you so much. Take care.